Good evening, class. Welcome to chemistry class. And today we'll be considering chemical combination. Chemical combination. All right. The first thing we talk about will be the laws in chemical change, laws of chemical change. When you hear laws, what comes to your mind? There are certain rules and regulations that govern the body. Rules and regulations that govern the body. If you consider a school system, there are some rules like the specific time in which you need to pay your school fees, right? And there are things like your class must be clean, it must always be neat. Ladies have to wear their beret. The guys have to use their belts, right? Your socks must be clean. The class must be very quiet. These are laws that govern the school system. Also in chemistry, there are certain laws that govern different aspects of chemistry. But in today's class, we'll be considering the laws that govern chemical change. And the laws that govern chemical change are called chemical laws. They are called chemical laws. So let's start off with the one we all know about, and that is law of conservation of matter. No one in this class is new to this law, right? And we can say it, or we can say it without even checking anyway. So let's echo it together. Law of conservation of matter states that matter can neither be created nor destroyed, but can change from one form to another in a chemical reaction. Let's go again. Law of conservation of matter states that matter can neither be created nor destroyed, but can change from one form to another in a chemical reaction. Emphasis on chemical reaction. Basically, this law states that matter cannot neither be created nor destroyed. Matter can neither be created nor destroyed, right? But can only move from one form to another. That means it can move from one state of matter to another state of matter in a chemical reaction. In our last class, I made mention of chemical change, right? That they are not easily reversible and new products are formed. So it's basically moving from the reactant to the product. That's what chemical reaction involves, undergoing different steps. Some can be one single step and some can be a number of steps. So from this law, we can see that matter can neither be created nor destroyed, but can move from one form to another. There are three states of matter: liquid, solid, and gaseous. So it can move around those states, but can never be destroyed, right? And can never be created. Something outside the reactant will not be created, right? And so this law simply means that the total mass of reactant is equals to the total mass of product. Total mass of reactant equals to the total mass of product. Let's consider this reaction. A plus B giving C plus D. It's saying the law here is saying that if A contains X mass, right, and B is 2X mass, the, the sum of this must give 3X, right? It must give 3X because it is 1X plus 2X, and that will give you 3X. It's saying that total mass of reactant must always be equal to the total mass of product. That means if A, let's give it a figure. If A is 2 gram, right? B is 4 gram, and we are told D is 1 gram. Calculate C. We know that total mass of reactant must always be equal to the total mass of product. That would be 2 plus 4 to give C plus 1. This is 6. This is C plus 1. Then make C subject of formula by taking 1 over. So it will be 6 minus 1, which will give 5. That means C is equals to 5 gram. Let's consider this reaction. 4 grams of hydrogen reacts with some oxygen to make 36 grams of water. Find the total mass of oxygen used in this reaction. I've written the balance equation: hydrogen plus oxygen to give water. We're told 4 grams of water react with some oxygen, so we're not told the gram of oxygen, to make what? 36 grams of water. From here, you can see that the product is water alone. And here, hydrogen is 4. We're told to calculate oxygen using the law of conservation of matter, which states that matter can neither be created nor destroyed, but we can change from one form to another in a chemical reaction. And we've concluded that sum of mass of reactants is always equal to the sum of the masses of products. So from here, we can determine the mass of oxygen. Mass of oxygen then will be the mass of water, right? Minus this, the mass of hydrogen, and that will be 36 gram minus 4 gram, and that will give 32 gram. So the mass of oxygen here is 32 gram. That is all about law of conservation of matter. But there is one thing here. You would notice that this is a balanced reaction, right? This is a balanced equation. So if you are asked that what law is associated to balanced equation, it is law of conservation of matter. Because before I started, I made sure that this equation is balanced. So let's move on to another law. Another law would be law of definite proportion. And law of definite proportion is also called law of constant composition. Let me write that law on board for us to see. Okay, so get this out. Okay. Law of definite proportion, also called constant composition, states that all pure samples of a particular compound contains okay. Law of definite proportion, which is also called law of constant composition, states that all pure samples of a particular chemical compound, all pure substance of a particular chemical compound contains the same element combined in equal proportion by mass. Let's take it again. State that all pure samples, pure, emphasis on pure, of a particular chemical compound, that means a certain chemical compound, contains the same element combined in equal proportion by mass. That means that all pure samples of a particular compound, let's say glucose, all pure samples of this compound contains the same elements. That's carbon, hydrogen, and oxygen combined in equal proportion by mass. That means no matter the method used for the preparation of glucose, no matter where it is being prepared, that means the geographical location, it will still contain the same elements in equal proportion by mass. That's to say, method of preparation, place of preparation do not affect the composition. Method of preparation, place of preparation would not affect the composition of a pure sample, of a pure sample. So if this compound is prepared in Nigeria, another is prepared in Canada, another in USA. This same compound, they will all contain 6, 12. 12 is the mass number of carbon, right? Plus 12 of oxygen, plus 6 of 12 of hydrogen, 6 of oxygen, right? This is what 78 gram of carbon, 12 gram of hydrogen, 96, let's confirm that, I think 98, that's 16 times 6, 96 gram of oxygen. This would also contain 78 gram of carbon, 12 gram of hydrogen, and 96 gram of oxygen. 6 times 12. Oh, 72 rather. 72, yeah. This would also contain 72 gram of carbon, 12 gram of hydrogen, and 96 gram of oxygen, right? So the law is saying that all pure sample of glucose from Nigeria, from Canada, from USA will contain the same elements, carbon, hydrogen, and oxygen in equal proportion by mass, So it's just saying that method of preparation, place of preparation do not affect the composition of pure samples of a particular chemical compound. Let's take a question around that. Okay. A pure sample is a question of water contain 14 grams of hydrogen, H, full stop. How many grams of oxygen is present? First off, let's write the chemical formula for water. So this is H2O, right? That's H ratio O. This hydrogen and this oxygen. That means it's 2:1. We all know it's 2:1 because 2 atoms of hydrogen and 1 atom of oxygen. We're told a pure sample of water contains 14 grams of hydrogen. How many grams of oxygen is present? And we know it is 2:1 and this is 14. We can calculate X, which will be the gram of oxygen, because we are aware that it will contain the same elements in equal proportion by mass, right? Because it is a pure sample. From here, we can also use the mass number. So from the mass number, we know this is 2, right? And we know this is 16 of oxygen. So we can work with this. And we are told 14 and this is X. From this, we can calculate the mass because we already have our mass here. Molar mass for this, atomic mass for this. This is 2:1. And so it should be 1 mass of hydrogen is 1. Mass of oxygen is 16. Since it's 2, so it is 2 times 1 to give us 1. And this is ratio 1. So 16 times 1 will give us 16. And so we are left with this. Let's calculate x. We cross multiply. So 2x is equals to 14 times 16. X is equals to 14 times 16 divided by 2. 14 times 16 divided by 2. Let's calculate that. That should give us 14 times 16 divided by 2. Give us 112 gram. That's 112 gram. Let's move on to another law, and let's consider law of multiple proportion. Law of multiple proportion. But before we consider that, let's go over this law again. Law of definite proportion, which is also called constant composition, states that all pure samples of a particular chemical compound contains the same elements combined in equal proportion by mass. So let's move on to law of multiple proportion. Law of multiple proportion states that if two elements A and B combine to form more than one compound, then the various masses of A which combines with the fixed mass of element B are in simple number ratio. The law states that if two elements A and B combine to form more than one chemical compound, then the various masses of element A, which combine with a fixed mass of element B, are in simple whole number ratio. Let's take that again. Law of multiple proportion states that if two elements A and B, right, combine to form more than one chemical compound, then various masses of element A, that means XA, 2XA, 3XA, will combine with a fixed mass of B in simple whole number ratio. Let's put a context to this. If hydrogen and oxygen, right, They can react to give water. It can also react to give H2O to this peroxide, right? From here, you can see that fixed mass of hydrogen combines with several masses of oxygen. Here, one atom of oxygen, and here, two atoms of oxygen. If we also consider this is copper, here you can see that copper is varying. This is one atom, this is two atoms, right? And oxygen is intact. So we are saying here, the law is saying that several masses of A will combine with fixed mass of B in simple whole number ratio. In simple whole number ratio. Let's consider C plus O to give Ca, C plus O to give CO2, and this will be 2, right? This is carbon, this is oxygen, this is carbon, this is oxygen. Carbon is one atom, right? This is carbon, this is oxygen. In CO, since it's one, it is 12 grams. Oxygen, one as well, one atom, and this is 16 grams. In CO2, carbon is one atom, also 12 grams. Oxygen, two atoms, that's 2 times 16 grams, that's 32 grams. Several masses of A will combine with A. Several masses of A will combine, several masses of A, here it is oxygen, will combine with a fixed mass of B, which is carbon here, in simple whole number ratio. So we can see here that this is, since this is 12 to 12, that is 1 to 1, right? This is 12, this is 16, right? And this is 32. So 16 grams to 32 grams will give 1 to 2. This is known as simple whole number ratio. Let me take that again. Law of multiple proportion states that if two elements A and B combine to form more than one chemical compound, here this is carbon monoxide, this is carbon dioxide, then various masses of element A, here it is oxygen, here it is 16 grams, and here we have 32 grams, which combine with a fixed mass of element B, carbon is 12 grams here, 12 grams here, are in simple whole number ratio. They are in simple whole number ratio, and from here we can see 1:2. Since several masses of A combines with fixed mass of B, and they do so in simple whole number ratio. Let us also consider hydrogen and copper that I usually go down. So this is hydrogen, this is oxygen in water, in peroxide. Hydrogen, from here, this is 2 atoms, right? So that is 2 times 1, which will give you 2 grams. Oxygen, 1 atom, 16 grams. Hydrogen in peroxide, 2 into bracket 1, which is 2 grams. Oxygen in peroxide, that's 2 into bracket 16, which is 32 grams. Several masses of A, that's oxygen here, will combine with a fixed mass of B, hydrogen here, and they do so in simple whole number ratio. 2 to 2 will give 1 to 1, right? Then 16 to 32, 16, 32 will give 1:2. They do so in whole number ratio, simple whole number ratio. Also in copper as well, you can see from here that the fix will be that of oxygen, and it will vary in copper, and they are in what? Simple whole number ratio, 1:2. Basically, the law states that if two elements A and B